In this video, we are going to create an image recognition project using deep learning approach. With the help of some popular libraries like TensorFlow and Matplotlib, we are going to do this implementation. Before we start this implementation program, we need to know about the neural networks. Neural network is a circuit of neurons which will group together and form a network, and then it will define the output. This is the simple one-liner about the neural network, but this is not enough to understand it fully. So I will give you some real-time examples on the neural network and you can easily understand what actually the neural network means. Okay, so let's start the explanation from its architecture. The structure of neural network is common for all types. Basically, it is a three-layered structure. The first group of layer is called input layer. It is used to take the inputs from the outsources. Here the outsources means the data set you have. And the basic characteristics of input layer is it only takes the input from the left hand side of the neuron and it sends the data to the middle layer. The middle layer is also known as hidden layer. This hidden layer processes the data and sends the data to the output layer. Finally, the output layer shows the output of your project. So this is the simple workflow of neural network, and here is my real-time example of neural network. I have one image and I don't know which character is present in my image. For recognizing the image, I created a neural network which is able to find the character that present in this image. Initially, we are splitting the image into three inputs. Here I have three neurons. Each neuron will take one of the splitted image from my original image. And then it will send the inputs to the hidden layer. So the hidden layer analyzes the image and it will give you some prominent scores, and that scores are provided by the hidden layer. Generally, the neural network will give you the scores in the scale of 0 to 1. If the score is equal to 0, then we can assume that it is not a low-key picture. If the scores are greater than 0.5, we can assume there is some possibility of low-key, and if it is 1, we can say it is a definitely low-key. Here the I1, I2, I3 are the scores which was generated by the neural network. But we need to give some prominent scores for evaluating this problem. Suppose the first input takes the images of low-key eyes, then we need to add some weightage values for the eyes of low-key. So we are having three images, we need to add three weightage values. So here is my question, how to add the weightage value. The weightage values are determined by the possibility of identifying the character. Some characters have some uniqueness in their appearances that will highlight the character more strongly. We have to give more weight to that particular feature. Here the I2 and I3 are the middle and bottom portion of the low-key image. With these two images, we can't assume anything. In this case, we need to give less weightage values to this feature. This is how the weightage values needs to be given in the neural network. Okay. After we collect the scores, we need to form a multivariate equation like this. So we need to evaluate this equation and it will give you some values. And if the value is equal to 1, then we can assume it is a low-key, otherwise we can't say it's a low-key picture. So this is the process of neural network recognizing the images. There are two important methods of approaching the neural network, that is the feed-forward network and backpropagation cycle. The feed-forward is nothing but it takes the input and it just processes the data and it will give you the result. So this is the process of feed-forward network, and the backpropagation cycle is a trial and error method. I will explain more clearly about this. Here we are having the low-key image, but at the end of the training, the neural network predicts this image is not low-key and it is a Thor. You can also face this type of situations. At that time, this neural network go back to its initial state and do some corrections according to the current result, and it will again do the prediction. That approach is called backpropagation. In the concept of reinforcement learning, mostly we use this approach. Some of the real-time examples are the video games that you play. Imagine you are about to play the boss fight in a game. In that level, you fail to defeat the boss. When you play that level multiple number of times, you will get some tricks to defeat the boss. Each time you play the level, you will get more accurate. That is the thing about the neural network. In the every training session, it will try to improve its accuracy of prediction. So this is the way of approaches in the neural network. So let's start the coding part. First of all, I imported three important libraries that are TensorFlow, NumPy and Matplotlib. The TensorFlow is used for creating the deep learning models, and NumPy will play the very important role for doing the conversion of multidimensional arrays. And finally, the Matplotlib is used to plot the data that are present in the dataset. So in the machine learning, we operated with the numerical data and visualize the data with graphical formats. But in deep learning, we are going to use the image samples. So that is the prime difference between the machine learning and the deep learning. And one more thing I want to share with you, that is, while installing the TensorFlow library, I suggest you to choose the downgraded version of TensorFlow. Here I am using the TensorFlow version of 2.4. When you are trying to install the latest version of TensorFlow, majority of times you will face the installation error. Okay, so go for downgraded version of TensorFlow. That will save some time from your project. Next, we are going to insert the dataset. Create a variable dataset and then we need to type tensorflow.keras. This is a syntax which holds the inbuilt data. Basically, the TensorFlow offering some datasets for practicing purposes. Here I just implemented the fashion dataset which contains 70,000 images with 10 categories of data. So let's do some exploratory data analysis. First, we need to split this data into two parts. We are allocating the 60,000 image for training purpose and remaining 10,000 image for testing purpose. This is the basic proportion. Suppose if you want to change the dataset proportions, we can take any number of proportion of data, but you need to allocate the maximum number for training. So just keep this in your mind. Okay. So let's check how the data is allocated. I have done some pre-processing analysis on the data. This will show you how the data is allocated in the variables. The image data is allocated in the variable train images, and the train labels variable show you the which category these images are belongs to, and this is also applicable to the testing side also. Okay, now we need to create the neural network layers for this project. Create a variable model and then you need to type tensorflow.keras. From the keras we are importing the flatten layer. This layer is pretty simple. It simply reshape your array. Here we are having 28 cross 28 array size values. This layer simply convert this multidimensional array into a single array. So this is the only thing this layer can do, and it doesn't have any other parameters. It simply converts the multidimensional array into a single dimension. Next we added the two dense layers. The first I will explain the middle dense layer and then I will explain the last layer. So in the middle dense layer I assigned 128 neurons and I gave one parameter, that is the activation of ReLU. ReLU is nothing but when the non-linearity equation gives any negative values and this parameter changes its negative value to 0. That's why we are using the ReLU method. ReLU is abbreviated as rectified linear unit. This is the process of ReLU method, and in the final dense layer we added 10 logits. Logits is nothing but we can simply say it is an output scaling method. In this problem we are having 10 categories of data. So we are only giving 10 values to it. Corresponding to these values, the output scale will change. I will show you while doing the prediction. So successfully we created 3 network layers. Now we need to add some important settings before we fit the algorithm. Here I added something called model.compile, and in this method I just passed the 3 arguments. The first argument is optimizer. This shows how the model is updated based on the data you have. It will measure the learning rate of the algorithm. Next one is the loss function. This shows how the model is accurate during the training session. Finally, the metrics is used to check how the data is fitted in the neural network, and also it will show you the accuracy of model after we train with the data. So we build the layers for this problem. Now we need to fit the algorithms into our training data set. So let's start the training process. We finished our training. Now our model is ready to predict the data. For that, create a variable probability model and then you need to type tensorflow.keras sequential method. Here we passed two parameters. The first one is the model that we created, and then we implemented the softmax method. Softmax will create a probability distribution based on the categories of your data. Okay, so this is the explanation about this block of code, and that's all. Let's check how this model predicts. I'm going to test this prediction against the test sample images. So I created a variable prediction, and in this variable I have done my prediction against the test images. Okay, now we need to select one particular image from the test data. So here I choose the image number 18 I don't know which category this image belongs to, so this program will now find the image category. So this program predicted this image belongs to number 8 category. The 8th category is the back, so the predicted image is back. Now we need to check with the original data. So type test labels and pass the image number. Let's run this block. You can see the actual value is also 8. So it means this program identifies as the image correctly. So that's all about this video. If you like this video, give a like and subscribe and share for more interesting scripts in Python. Thanks for watching and thank you. See you on next another video.